Right. So you tried on your own, and this is what I have to compare with. First answer, x equals -4 with happy face, and then second answer, x equals -5. No happy face on this one. I did two different methods. Like this one, I just did the least common denominator, and then basically at that point, once the denominators are the same, I just created an equation with the numerators. And then second example, the least common denominator, I multiplied just on the top. You don't see me multiplying the top and the bottom, but then you're seeing that I'm dividing. If I multiply this one by 6, the 2 on the bottom is going to leave a 3. If I multiply this one by 6, the 5 is not going to change. And if I multiply the last one by 6, there's a 2 behind. There was already an x there, and so it makes a 2x. So you can use either method to get the same answer. Things start to get a little more complicated in round 2 here. Please write down this example. This is more complicated because you have binomials. You don't just have like a 2 or 3x. You have a minus sign, and if you remember from last week, if you see something like this, you can't just cancel that out, right? So this idea of creating a common denominator is true when you can think of a number that multiplies into a larger number, and that is counterintuitive when you see addition and subtraction. They're not in the same family, I think I call it. So you want to understand 3x minus 12 as its factored form, that this is a 3 times x and a 3 times 4. So if I'm looking for a common denominator, x minus 4 is a factor of this first one, and 3 is also a factor of that one. And so the least common denominator is 3x minus 12. So again, hopefully you've had the chance to copy this, and good thing it's video, you can pause it. But I'm going to do the same process. It's just more complicated when the denominators have addition and subtraction symbols. Be very cautious of how you cancel, and what you decide is the common denominator. So I'm more on the side of like just multiply by what you need. I often textbooks teach you to multiply each one by the common denominator to cancel things out. But I'm more like, if they have a common denominator, you can just ignore the denominators and make a an equation out of the top. So I see that if I were to multiply this denominator by 3, they would match, but I can't just multiply on the bottom. I also have to multiply on the top. And then this last fraction is the most complicated. And so I'll multiply by parentheses x minus 4, so that these 3 fractions all have the same denominator. And when I do that, I have to remember to use the distributive property. So again, what's left is this numerator is the only thing I have to worry about. So this, I didn't affect the 7 because this first fraction had the common denominator. There's a subtraction. The 1, I had to multiply this by 3 on the top and the bottom, so this is going to be 3 times 1. So this side of the equation ends up being pretty naked, or like there's not a lot left. There aren't any x's over there. And then on this one, after the equal sign, that's when I was mentioning you've got the 2 and then the parentheses, so you have to make sure that you distribute. So on the left side of the equation, this will just be 4, and then 2x minus 8, or, how savvy you are with solving equations. I could have just divided the 2 on both sides. I didn't have to distribute it in. But once it gets to this level, it's like, you got it. Hopefully, you add 8 to both sides, you'll get 12. Divide by 2, you'll get 6, and that's your final answer. And then just make sure it wasn't any of the excluded values. So remember your excluded values. In this case, x cannot be 4, and that's okay because my x fixed. So these are definitely more challenging. And so I have several more examples for you. 1, 2, 3, 4 more to do with you. And hopefully you start getting the hang of it. Okay. So this next one is a little off because the examples I've been doing have all had 3 fraction parts to them. This equation, the way I see it, has 3 parts. You know, you've got this fraction, and then you've got the whole number 2, and then you've got the fraction at the other side of the equal sign. And so whole numbers can be fractions. Integers are part of the rational number family. And so the way I see this denominator is a 1. It's the only one that doesn't match. X plus 4 is the common denominator. It has to be viewed as a factor x plus 4. And I'm going to multiply by x plus 4 on the top and the bottom of this fraction to make an equation that I don't have to worry about the denominators anymore. So if I change this to 2 times x plus 4 all over x plus 4, this is still 2, like that yellow piece is still 2. And then on the other side of the fraction, I have x over x plus 4, and then this green part of the fraction, 4 over x plus 4. And so now all the denominators are the same. I leave the top, and that is my new linear equation that I have to solve. And I believe in you. You can do it. Hopefully you already started. I am trying to give you time to do it. Okay, so then it's 4 plus 2x plus 8 equals x, and then I would subtract an x. These make 12, I'd subtract that. I think that's right. And just make sure it's not excluded. It's not. The only excluded value is -4. And that's not what I got for x. And, simpler equations you can check. I'm looking for different colors. So if x were -12, -12 plus 4 is -8. 4 plus 2 times -8 should equal the x, which is -12. And that looks like it's going to work out just fine. 4 subtract 16 is -12. It works out. Okay. Oi. I said I was going to do several examples, but it looks like I messed up example 3 because I didn't make it equal to anything. So that was my mistake. Actually, I could use this as an opportunity to talk about what happens if you have a proportion. A proportion is a fraction that is equal to another fraction, which is not like what I've been doing. The other ones were like this plus this equals that. There's like 3 parts. But if you just have one fraction equal to another, you can use what's called the cross product. And that's another way of, it's true, if you think of 2 fractions that are equal to each other, like 1/2 is equal to 4/8, and I multiply these 2, I get 8, and I multiply those 2, I get 8. So a lot of things that feel like tricks in math, it's just because somebody noticed they're true, and they're like, hey, you can do this. So anyway, I'll use this as an opportunity to talk about proportions. So if you do have one fraction that's equal to another fraction, you're essentially doing the same thing. The common denominators, both of these things multiplied by each other. But you could do this. I've heard of a teacher call it the butterfly because it kind of looks like a butterfly. And when I say do this, you're going to take the top of one fraction and multiply it across to the denominator of the other one. And that's going to equal what you get when you do that with the other 2 combos, the numerator and denominator of this like diagonal product. And then you solve that. 6x minus plus 18, x plus 2, subtract x, subtract 18, -16. Make sure it's not excluded. It's not. Sorry, and you're welcome. So, yeah. Let's move on. All right, again, I know this is not ideal. Happy Thursday, and the goal of this video was to show you how to solve methods of solving rational equations with rational expressions in them, and it's all focused on the denominator. And so this next one seems very similar to this one here, right? I've got a whole number as part of the equation, and then these two are the same, very similar problem. And then this problem reminds me a lot of what I did at the start of this second video. This guy right here, that the first one has two factors, 3 and x minus 4. And that's what you see sitting in those positions there. So I'm going to rock and roll. Let's do it. And then I have two more for you to try. You can pause the video and then I'll show you the answers. Okay, so this one, again, very similar. X minus 4, you can't view it as two different things. X minus 4 is the denominator. It's not x is the denominator, -4 is another piece. And so what I'm going to do is I'm going to take this one and I'm going to multiply it by x minus 4. And then basically what you could do is if x minus 4 is your denominator and it's your common denominator, remember there are two different methods. Like this is one method. Just go through, multiply each one by x minus 4 and see what happens. These cancel, nothing cancels here, which leaves that, and then these cancel. And so the equation that you could solve that will give you an answer, but it won't be so complicated because there aren't any fractions involved, will be that one right there. Distribute here, 2x minus 8. Combine like terms here, 2x minus 5 equals 5. Add 5 to both sides. 2x equals 10, x equals 5. Not an excluded value. Happy. Okay. Last one, again, 2x plus 6 is 2 times x plus 3. So if I just multiply this fraction by 2 on the top and the bottom, multiply by 1, which is 2 over 2 is 1. And then on this one, I'm multiplying by 1. Ooh, this one got a little spicy because it's going to be quadratic. So, yeah, that's different than the others, but we'll see. Let's do it. So now that I see that all the denominators are the same, I can just ignore the denominators and rewrite a new equation with the numbers that are on top here. X squared plus 3x is what I get when I distribute the x. So I said this will get a little spicy. In this section, P.7, there are also quadratics. I didn't do the problems myself to see if any of your rationals turn into a quadratic. And so if they do, just know that help is on the way, and I'll do another video for Friday for quadratics. And I'm just going to continue on, and maybe you'll remember stuff about quadratics from your previous schooling. So when I solve a quadratic equation, the easiest method is when the quadratic is factorable. I feel like we did this when we were looking for excluded values. So it's not that spicy. Or you've acquired the taste. So then the rationale is if I have anything as an equation equal to 0, and I could change this side of the equation into the product of two numbers, that the argument is, well, if this times this is 0, then one of those two things has to be a 0. And so if the first one is a 0, it's because the x is -2. And if the second one's a 0, it's because the x is -1. And so these are your two solutions. These are more complicated. And so again, don't forget to double check the excluded values, and these neither are excluded from the beginning. So we're all good, right? There, please copy these and do them. Copy them down and please pause the video and I'll work along with you, but I recommend that you pause the video. All right, pre-calc, that's that. Again, try to make the best of a not so great situation as always. And here are the solutions that I got. Again, neither one's excluded, so that's good news. And I think with that short video, short, you should be able to do this assignment. So please continue on and do these problems. I think some of these are not as difficult as what I showed. I will double check what this little section is, 61 to 65. But you should do this as homework so that you don't fall too far behind. Thank you, and I'll see you soon.